Welcome everybody to my presentation. I'm going to be talking to you today about Azure IaaS, that's infrastructure as a service, proper sizing and cost. As I said, my name is Robert L. Davis. I'm a principal database architect with DBBest Technologies. I am a certified master in SQL Server as well as an MVP in SQL Server. And if you would like to contact me, the easiest way is just to find me on Twitter as @SQLSoldier. So this is the area of Azure that we're going to be talking about, this section down here at the bottom called Infrastructure Services. So IaaS, Infrastructure as a Service, or as what you may commonly refer to as VMs in Azure. So a lot of people like to take what I call a traditional approach to migration. So they migrate a server up into the cloud. They will look at what resources the server currently has, find the server in the cloud that has the closest resources to that, and move that server up into it. Then they'll move the next one up into another VM, and they'll continue on until all the servers they want to move have been moved up into VMs. So they end up with a 1-to-1 ratio of servers that they started with on premises or in their private cloud, and they've moved them up into Azure. It's easy to do it this way. It's kind of safe because you're getting better at, or if not the same performance of the servers up in the cloud, but it's not very cost effective because you're moving from old servers to a new platform. So your infrastructure in your current systems probably 2, 3, maybe even 5 or more years old. So they're not the most current CPUs, and CPUs get stronger and faster every day. So you're not going from the same hardware to the same hardware. So your needs, you don't need the same amount of power in Azure as you had in your old system, because everything's faster, everything's stronger. There's no consideration given for the performance difference of the old system to the new system. The CPUs are faster and stronger, network is better, the I/O is better than what you have in your old systems. Since you're not giving any consideration to those, just moving things up with the same size, you're spending a lot of extra money for resources that you don't need. And no consideration is being given for whether the server was properly sized for the workload in its current environment. So as I said before, you're starting out with hardware that's 2, 3, 5, or maybe even more years old. And we do capacity planning along the way, and we try to figure out, okay, what resources is this server going to need in 2 or 3 years from now? But very rarely do we get that number exactly right. So what we end up seeing is we see a lot of servers that are grossly overpowered for the workload that they're handling. CPUs running at 10 to 20% most of the time, or 16, 32, 64 gigs of memory, and it's only using a small percentage of that. So if you're moving everything to Azure with the same resources, it's not only is it going to have, it's going to have even more unused resources than it has in its current environment. So you're really throwing a lot of money out the window by taking this approach. So we like to take a different approach, what I like to call looking at the VMs as workload containers. Rather than just saying machine to machine, this machine to that VM, this machine to the next VM, we take a look at the workload as a whole and precisely measure your own premises workloads. Then we precisely calculate the performance difference of your existing infrastructure to what we have up in Azure. CPUs are going to be faster, they're going to be stronger. I/O is going to be faster in Azure. The network's going to be strong. So you're going to see a lot of difference in performance. So not only do you not need to go up with the same size VM, you probably don't even need what you have, the hardware you need in infrastructure, in your current infrastructure. But you can't just throw that away. But by properly sizing in Azure, we can save you a lot of money. Then we determine the cost of variable combinations of workloads. We don't just say, okay, get the biggest Azure VM and keep adding servers to it till it's full, then move on to the next one. We actually take a look at different combinations of workloads to see what can be combined on different machines and determine if they are a good match together. And we eliminate the ones that are all but the one that's the most cost effective. Maybe a big machine, it may be a small machine. And we calculate your exact cost for you. Particularly with SQL Server, licensing is a big portion of your infrastructure costs. And that's going to, if you just move everything up with the same number of cores and all the same resources and the same number of machines, your licensing costs are going to stay the same, and that's still going to be a huge portion of your infrastructure costs. But if you take a more calculated approach like we do, you combine things that can be combined, you measure things and give it only the number of cores that are actually needed, then you can end up with saving a lot of money in licensing costs. Maybe your machine had 8 cores on the old system and infrastructure, and then when we profile it, we see it actually only needs 4 because it's using such a low percentage of CPU. On the existing ones, it only needed 4 CPUs. That right there would cut your licensing costs for SQL Server for that machine in half, saving you, you can save tens of thousands of dollars this way. And then when we calculate in the performance difference of the new systems, maybe it only needs 3 or 2 CPUs. Maybe it doesn't even need 4. So, and by combining machines together, instead of having, say, for example, instead of having 4 8 CPU machines, you can have those 4 share CPUs on an 8 CPU machine. So now you've gone from paying for 32 cores of SQL Server licensing to only paying for 8 cores. That would cut your licensing for those machines into 1/4. You would cut 75% off. So as I said, it all starts with measuring your existing workloads. And typically when we do this, we're looking at your entire infrastructure, not just a few servers. So we're looking at hundreds of servers. And there is no way to do this manually in an efficient manner for hundreds of servers. It has to be done programmatically. So we have proprietary software we've built that will go in and gather all the profile performance metrics of all your systems. It'll tell us exactly what not only how much CPU you're using, what the model of CPU you have, and we know exactly what the power and capabilities of all these CPUs are. And then we profile that to match it up to the Azure capabilities, and we're able to determine a ratio of what the power is of the power and speed of your existing CPUs to what is available to you in Azure, and we can tweak the calculations for that workload to say, okay, on your existing servers you need 4 CPUs, but up in Azure maybe you only need 2 or 3. So we're able to map that up to the exact power and strength differences of Azure. And we can do this with, we profile your CPU, your memory, your network I/O, the size of your network packets, the disk I/O, the size of your disk reads and writes, how much of your data on disk is actually changing, how much total disk space do you need, and we can factor all that into the Azure calculations. And that's the step 2, calculate the performance delta, where we figure out what the actual differences between the resources you are using versus what you need, and what you would actually need up in Azure when you're running on better, faster hardware. And then we test variable combinations of workloads. As I said, we don't just say, keep loading up VMs until it's full. We actually figure out which workloads will work well together. We try different combinations with different size of Azure VMs to figure out which combination would be most cost effective. So it may be a big size, it may be a combination of smaller sizes to combine the workload onto. What we typically find is that it's a mixed bag of the VMs that you end up going to. So I want to talk a little bit more about how we do that, those variable workloads. So we're looking at hundreds of machines here, and this actually only shows a few in this example, but typically we're looking at hundreds and hundreds of machines. And so we will consider all variables of combinations of servers as to, exactly which machines fit on which VMs, test out the different sizes to figure out, okay, what will fit where based on resource needs, and then we figure out what's the most cost-effective one. We eliminate all but the most cost-effective answer for a set of machines, and then we remove that set of machines from the pool that we're calculating this for, and we repeat that process. So now we've got, in the previous example, we came up with putting 4 machines on Azure D14 system. So we remove those 4, we recalculate with what's left, and we come up with a different set of parameters. We figure out what's the most cost-effective one for those workloads, and we remove them, keep repeating this process till we've calculated exactly what is needed for all of the workloads. So this is an example from an actual output from a customer engagement we did, where they had a huge on-site licensing cost, and they were actually looking to see how they could reduce their licensing costs. And so this is an engagement we did. The performance metrics were used to determine what their on-premises capacity was. The server capacity was combined with Azure pricing to determine the cost of running the environment in the cloud. And then we determined the cost of running in both a consolidated and non-consolidated Azure environment with the following summary. So this is a little brief summary where we show if you do the one-to-one in Azure, and there are a lot of tools out there that tell you they can help you estimate your cost in Azure, but this is the part that those tools are giving you. They will give you exactly, they say, okay, this server has 8 CPUs and 32 gigabytes of RAM. This is the VM that fits in. So what most of those tools out there are giving you is the one-to-one, moving VM to VM in Azure. So we tell you what that cost model will be. And we can show you, in this instance, they had a total of 894 SQL cores to be licensed up in the Azure with the one-to-one, moving to 207 cloud servers from 241 current servers in the infrastructure, leaving 34 that were decided weren't good fits for Azure, and they decided to keep those on-prem. Whereas with the consolidated Azure, where we ran our VM as container model on them, they ended up with a core count of 554, huge difference, about 340 cores less that don't have to be licensed, that they didn't have to license for SQL Server. They ended up only using 47 cloud servers. 160 less VMs were actually needed for their workloads. Going from 241 servers with 34 staying on premises. And we were able to show them, this is what your storage is going to cost you per month. This is what your storage transactions are going to cost you per month. This is what your network is going to cost you per month for these systems up in Azure. And we give a big full report out. We tell you exactly which servers go to which VMs. Everything's mapped out perfectly for you. We break things up logically based on how you want to break up. We can break it up based on whether you consider production, non-production, DR, so that production and non-production don't end up getting mixed up in Azure. So you can keep it broken out. We tell you, in this specific example from this client report, you see we're moving to 7 different types of VMs. A majority of them are actually going to Azure D14. There's a mix of different types of VMs in there. And so this is from a client engagement that we did for them. This particular client had 852 cores of Enterprise Edition and 840 cores of Standard Edition on their own premises infrastructure. They actually only owned 292 licenses. So it was time for them to true up their SQL Server licenses. And that's what triggered this particular engagement. They're like, wow, we only have 292 licenses and we need almost 1,700 licenses. That's going to be a lot of money. So they were looking at having to buy 1,400 additional licenses, and the amount it was going to cost them was an extra $6.7 million just for the SQL Server licenses. And then based off of their own cost tracking that they do, their hardware and operational costs for their own premises infrastructure was $3.387 million a year. And so for moving to Azure, we showed them the 2 different options. Moving to Azure with the one-to-one VMs, where you keep the same number of licenses. They were going to end up with our move one machine to one machine. We were able to help them cut down the amount of licenses to the amount that they needed based off of the profile. So we didn't actually move it up. We're not moving it up to the exact same size hardware, but it's still going up on a one-to-one basis, but it's going up so that it's calculated on what's actually needed. They actually ended up with a lot less enterprise licenses and actually more standard licenses than what they were currently running with. So we also identified for them which of their enterprise workloads could run on standard edition in the Azure VMs. So their licensing cost goes down to $3.8 million. That's a huge difference from the almost $6.8 million down to almost $3.9 million. That's a huge cost difference. And as I showed, we calculate what their operational costs for Azure are, and that came out to $1,036,000, and this is per year. So this is $1 million per year versus $3.4 million per year. And then their remaining SQL on premises, they still have most of what they were keeping on premises is Enterprise Edition. So they actually ended up with 96 more Enterprise Edition licenses than they needed, and needing 12 Enterprise Standard Edition licenses for SQL Server, which actually works out to saving them $800,000 on the licenses by converting some of those licenses. And it still leaves them with about $285,000 of operational costs for their own premises servers. Now, and then the second option we gave them is to consolidate the VMs, and they went there. We were able to take them down to 228 Enterprise Edition licenses and 228 Standard Edition licenses. That's a huge cut down from 280 and 628 to 228 and 228. So we were able to cut the number of licenses by consolidating workloads onto the right-sized VMs for them by a tremendous amount. We cut down their licensing to $2.5 million from almost $6.8 million. So that's a savings of more than $4 million in SQL licensing alone. And their yearly hardware operational costs are actually only about $457,000 for the Azure operational costs. They still have the same number of servers remaining on premises, with the savings of about $800,000 in licensing there, and about $285,000 in operational costs. So their 3-year Azure consumption, they're looking at paying for 3 years, $1,522,000 for their Azure consumption, and the total Azure spend of $3.2 million for Azure in 3 years. They were spending $3.3 million a year to run their infrastructure on premises. So with this model, their Azure for 3 years is less than what they were paying for a year on premises. Thank you everyone for joining the session today. I hope I've opened your eyes to a new way of thinking for moving your systems to Azure. A lot of people say Azure isn't saving them the money they expect it to be, but as you can see, if you apply some logic and a lot of work to it, you can actually save a lot of money by moving your systems to Azure. Thank you.